welcome. This is a bird of a feather session. Let's start. This is going to be an open discussion. The guidelines are that we have a couple of slides to set the stage, set the background for the conversation, and then open the floor to input from all the participants. A few weeks ago, maybe a month ago, not more than that, we got inquiries from few members from the Light group, the IoT team, about looking into open source embedded graphics for Cortex-M microcontrollers. These are some snapshots of some existing embedded graphic frameworks running on Cortex-M. So this is the kind of graphics, and you may recognize some use cases that may be of interest to the members. So this is what we have tried to look for. So the idea is to look into what can be accomplished with Cortex-M class devices. Several of the available Cortex, especially M4, have an embedded 2D acceleration IP in hardware. Some do it equally well in optimized software code. So we have been looking at the offering on the Cortex-M side, and we have been looking at the tens of graphic frameworks and toolkits that are available for embedded and specifically for Cortex-M devices. Out of the tens that we have looked at, only one or two may be somewhat open source software. There is one which is really true open source software, only one. So, open questions. Is there a value for Linaro and our members to work on an open source embedded graphics initiative for Cortex-M?
Could I ask a different question to start with? Out of all of those, what is their interface to the hardware? Is it simple pins that
I'll get in a minute. So I'll show you the list of Cortex-M devices that we have looked at, and the list of the UI frameworks that we have looked at, and the hardware primitives or functionalities that are supported. And then the feedback that we will be seeking from the audience is if there's a value, if there's an interest for you to see an open source embedded graphics framework done as part of Linaro, or maybe what is available is cheap enough and good enough, and you're not interested in an open source framework, but nevertheless you may be interested in a common set of 2D primitives that could be deployed across all the member Cortex-M devices and used with the graphic vendor providers, so that it can be you can easily pick and match Cortex-M and UI frameworks. So these are the inputs that we are seeking today. So this is the list of Cortex-M devices that we have been looking at. Those four are those that have interesting 2D acceleration capabilities. I'm reporting public information that you can find from the web. I'm not disclosing any confidential information from any member. So everything is public from the search engines. So those four are those that have interesting 2D acceleration capabilities. This is more or less the summary. I'm not pointing at, of course, which SoC is providing which acceleration. We're always staying at a fairness level with all the members. But in a summary, these are the features that are supported. The basics are bleating bitmaps. Then you can do bleating with read, modify, write, so you achieve blending. You can go as far as filling rectangles on the display or copying areas from off-screen to on-screen or within the screen itself. Some go even further and they provide the ability of drawing lines or polygons or even curves. Some even have anti-aliasing, alpha blending, texturing, which seems pretty wild for a Cortex-M, but it's available. Most have multiple hardware layers, so that you can have one layer for the graphics, one layer for, some provide some imaging capabilities, so that's where you have multiple layers. Some have a text layer and a graphic layer. Some provide hardware cursor support, so it's the old good sprites from the old days. In one case, I have even found specific hardware font rendering, which can be achieved anyway with the rectangle bleed and blend. If you have the fonts as monospace fonts in memory with an alpha channel, the blitter is good enough. So I'm not sure if hardware font rendering is a specific feature or is a reuse of the blitter. But anyway, this is the summary of the features. I was fooled, and it was fun. In one case, I had found an accelerator that was 2D advanced animation and control engine. And that was even providing start point, end point, speed, frame rate, animation. That was pretty powerful. And then I discovered that, well, that was a Cortex-A plus Cortex-M. And that acceleration was for the Cortex-A part, and the Cortex-M was a coprocessor. So I was totally off track on that, but it was interesting anyway. This is the list of the graphic toolkits that I had looked at. MicroGFX, Ambient, Express Logic GUIX, which is a takeover of Prism that some know. Sega, the company in Germany building the low-cost debuggers, and they have recently come up also with RTOS and other embedded libraries. Micrum, those from the MicroCOS, they also have a MicroC GUI. Interestingly enough, the same snapshot from the website is available from Sega and Micrum. It's exactly the same snapshot, so I wonder if there's any cross-licensing between the two. TouchGFX, Tara Systems, eGUI and PEG are interesting, and I'll come to that in a minute. In 99% of the cases, source code is open, but it's not open source. You can get source code, but you have to pay for it. There's a commercial license associated. No royalties, but there's a prepaid buyout NRE, which ranges from $1,600 to up to $20K, depending on the features that you select from the offering, from the menu, and depending on the expected volume of your product. So they all support the standard widgets. I've not listed them. Radio, checkbox, all sort of list, sliders, all support font. Almost all support anti-aliasing. Some support multiple display as interfaces toward the display controller. Some go one step further, and they provide additional widgets like gauge. That's more for industrial when you see the pressure of the valves. I've seen one case, the toolkit is able to create on the fly QR codes. One toolkit is providing calendar, a couple of toolkits are providing a virtual keyboard. So there's a common set, and then there are extensions depending on industrial control, HMI panels, or more consumer. all provide a IDE environment with an emulator running on a PC. Some it's Windows only, some it's Windows, Mac OS, and Linux. And they all provide a GUI design tool on the PC. On the code size, it varies. If I'm not wrong, 6K should be the minimum ROM code or execution code that is required. RAM depends on which modules you enable in the build and the size of the screen and the color of the graphics. So as I was saying, they are all under commercial license but one. No royalties.
So quick question, Andrea. So yesterday we had a discussion about tool chains in MC Pro to use artists, etc. And it seemed like there were not only lots of artists, but lots of compilers with different options. So these things presumably are built by the compilers that go with the artists.
Yes. Yeah, all these frameworks are tested against different RTOS and different tool chains. So you find the usual suspects. The usual suspects on the RTOS side and the usual suspects on the tool chain. That's correct. What else? One of these is purely binary. The source code is not open, and you buy pre-built binaries. There's one. All the others provide source code as part of the license. eGUI D4D is the only one that is truly open source. I'll upload the presentation. Every logo is actually a hyperlink, so when you download the presentation, you will go directly to the web pages. eGUI is the only one that is truly open source. It was initiated by Freescale in 2014. I've downloaded the Git. I think it's on GitHub. So I downloaded the Git, and the first commit was from 2014, the last commit from December 2016, so reasonably maintained. It's around 70 or 80 commits overall. And it provides the basic set of all those functionalities. And it's released under the LGPL with a specific additional clause that the library can be statically linked with any other code with any other license. So the LGPL is applicable to the changes that would be done to the eGUI, but does not propagate to any other component that is linked with the library. I think three. What? Three. I think V3. Yes. So this is as far as my setting the stage goes. I've got two mics, so I would just like to go around and get some feedback from the people in the room. If you have any interest, at which level an open source framework, which includes up to a GUI design and emulator, or if you are not interested at all, or if you are interested maybe in the set of graphic primitives to be shared as a common base across many.
Do you have an answer to Dave's question about how the devices connect?
In a couple of cases, they have a hardware acceleration layer, yes, specifically for hardware acceleration, and already ported with at least one Cortex-M IP. And I'm sure one is ExpressLogic GUIX, and there's another one I should look into my notes, but there were at least two which specifically support hardware acceleration. All the others have primitives with type def, with structures about pointer coordinates and the usual suspects. Some are in C, some are in C++.
So, not to pick anybody in particular, because I've looked at the software. Thanks.
So I've looked at various bits of software when I was looking at Zephyr and MCUs and STM's Cube stuff I know. And that allows you to kind of pick and mix and go press a button saying, I want this, I want that, I want the other. And it generates a bunch of code that then compiles. And I guess that the graphic stuff is linked into that as part of the offering. Yeah?
Sorry, Eric.
Well,
It's
you're welcome. Indeed, we as ST, I mean, we make available for our customer a solution, graphic. Now STM32 is, thanks to God, pretty popular, and basically all these guys, besides the IGUI that is open source, well, even IGUI, by the way,
No,
is
even
available.
IGUI is
Yeah,
supported,
it is available on STM32, but it is commercial deal.
The point
But
is it's bundled in with your added value, which is a library around it where you can very easily make it happen.
yeah.
Yeah, rather than porting code and messing around with bitmaps. Yeah, okay. Which I think is true of a lot of these. I think they're related to a GUI tool build.
Yeah, I think many Cortex-M support many frameworks, and
Yeah.
there's a pretty good coverage.
And these are years old. I mean, these have been around nearly as long as I have in this industry.
Prisma is one of them.
Yeah, well, on this, what we see from our side is we see some demand for graphics, but pretty stable, meaning that I mean, in terms of technology complexity, of course, the look and feel evolve over time and so on. It's let's say nicer and nicer. Of course, it depends on your how you see, but there is some evolution. But the technological requirement behind it is we see it pretty stable. As mentioned by Andrea and other colleagues, we have some hardware accelerator that is, in our case, a 2D DMA with basic functionalities that Andrea mentioned. And this is pretty stable.
Yeah, so old, established, part of the value chain.
And to finish, as I started, now in terms of open source, as you mentioned, there is not so much solution as far as we are aware. And IGUI, the status of IGUI is not so clear to us. I must admit that I discovered it when you mentioned it to me. So if there is something pointing out and really establishing on the market next to the others, well, basically our policy is to have our platform available for all the solutions. So we look at supporting it, but so far there is no candidate, let's say. Maybe beside IGUI, but to be proven.
Yeah, and another one is PEG Lite, which is developed by a software division of NXP Freescale, and it's available under commercial licenses on all Cortex-M and available under free license for NXP customers.
So what's TI's approach to this? You knew I was going to ask.
So many of our parts don't have direct LCD pins directly. So people still do graphics, but it's
GPI and wiggling, whatever. Right?
well, it's I2C or SPI to an intelligent device, right? And so acceleration doesn't make any sense in that environment. Any acceleration that needs to exist on the far end of the wire. But you know, I think those UIs look interesting. I think the UI's demand that we see is pretty simple. And you know, even if you want to make it look pretty, it turns into blitz instead of draws. But
There's no push to change. It sounds like stabilised now. This stuff will drive a little screen on a device, or you know, automotive.
yeah,
in a car or
it would be interesting to me if we had something that we could point customers to. Hey, if you outgrow our stuff, you know, here's some interesting things you can do and how to set up. So what we do provide to our customers, it's a BSD licensed graphics primitive library that gives you, you know, the basic primitives, so you don't have to code them yourself. It's BSD licensed, and they can do with it whatever they want. It's, I don't know of a burning need to change this, but the other thing on, my intuition says our customers would be allergic to anything that was LGPL v3, even with that license, right? Even v2 I'm worried about, because it means you end up having, the code distribution problems for the end product. Most of these guys, they're just now coming into open source.
So it's pretty stable, and they're kind of BSD comfortable because it's derived license.
BSD or Apache or something. Permissive license is good. I'm not. Yeah.
Okay, cool. And sorry, once you go beyond this part, then you end up in Cortex-A, and you've got a whole other thing going on. So there's like this stuff, and then there's Cortex-A.
But I wasn't thinking about that until I was listening to Andrea talk. Another area where this is potentially interesting is Cortex-A, where we do have a GPU, but running an RTOS.
Yeah.
So when we're running an RTOS on Cortex-A, maybe they do want to draw a simple UI, and maybe they don't want to use the GPU to bring that into the code base. That might be it. But still being able to have a more
Trolltech's cute. Well, it used to be Trolltech. Qt used to be quite
yeah,
big, but
with the move to GPL v3,
that kind of nixed it.
Even there is a commercial buyout for Qt,
Right.
And that's their business model. But yeah, some customers may not. But yeah, you're right. That would probably be a good answer there. But.
Okay.
So bottom line, you were saying a set of 2D libraries is what you see as what TI is providing and what your customers are looking for. So any value in possibly looking at a common set of libraries across Light?
We'd have to understand what we got from it, right? So there are problems, right? If unless TI goes and integrates our 2D API into each of these, it's a problem for our customers that want to use that, right? So that would be an advantage. Like I said, most, if the graphics hardware is actually in your chip, you can do all the work. If the customer is connecting an I2C or SPI-based graphics board, well, each of those, the way they,
They're all different.
they're all different. They all have weird pixelation techniques and things. So there's how you translate your in-memory frame buffer out to the SPI and do that is per device. So having a library of things that people could easily adopt different device and devices would be interesting. But this is not a burning desire in TI that we're going to put 10 engineers on, right? It's
steady
nice to
state.
have
It's
if
been
somebody
done,
builds
it's
it.
cheap, and every time you bring out a new chip, you make sure it still works. Yeah.
Thank you. Mando, you had a comment.
Well, this is not really a comment, but an advertisement for a course or for a session that's going to be on Friday from 10 o'clock to 10:25. It's entitled A Functional Open GPU Upon ARM. It was a comment I made to Professor Zufo that you could make a GPU out of an FPGA, and 3 months later, 2 of his students had done that. All of the code for making the OpenGL compatible GPU will be open source, and I invite you to come and see the talk.
Okay, that'd be interesting.
This has been done before in Intel platforms. As far as we know, this is the first time on an ARM platform.
Okay, so in the last few days I got input from and chat from Bill, Eric, Rob, who is busy in a meeting. I also got some comments from Gang. Would you like to share your thoughts? If you want, I can project the slides, or you can just share your comments.
Actually, our requirements are very similar to Bill's. Yes, for the Cortex-M-based chips, we have very simple requirement regarding graphics. So currently, we don't need anything, and we may need some simple text display, but that's all for Cortex-M. But we do have some Cortex-A chip running RTOS, and so it's the same thing. And we need graphics, we need UI for that, and yes, so this survey is very interesting for us, and we hope we can have some full function UI, but currently it's some early phase for us, so I cannot define it accurately. So, but it's good to have the full function UI for us. Okay,
Thank you.
thank you.
Any comment from ARM?
So, I mean, obviously this is things that are coming in the future, but I mean, they're certainly looking at trying to make the Mali 400 small enough to fit in the embedded device space. And I mean, if Linaro went ahead and created a framework that was open source to support 2D graphics, we have agreement that we could link that into the hardware acceleration. So there is certainly interest in the industry for this kind of thing, even down on the Cortex-M and definitely on the small Cortex-A's.
Push that driver into the
Yeah, I was going to join in on BSD or Apache is the place to be. I mean,
Well, that seems pretty the consensus.
yeah, I mean, if you're in this kind of space, yeah. Nobody wants GPL.
No. Well, that's a definite output for the meeting. Which is, you know.
But obviously, it kind of, what we actually do depends a little on the pull from customers.
And a general framework is possible, right? But I don't really know graphics that well.
When you would create a software 2D framework library with ability to configure into a HAL layer that allows for hardware acceleration, because what the Mali accelerates is different to what other people's.
Yeah, no, I just didn't know whether it was so invasive, the way things work was so different and so invasive, or is it just proper engineering you can create?
It's a very stable area. Doing 2D functions I don't think it's that difficult a problem.
So I'd be curious to know, just from the SoC vendors with when they work with these various companies, is there a burden that's put on you, or do these companies take it on as far as supporting your hardware? And is there a benefit that would be seen by having some common interface, you know, towards reducing porting efforts and so forth, even to these commercial products in this space?
But I think STM stuff has pretty independent interfaces into accelerators and things. So I think they're generating code and interfaces as you make choices. So there's a little bit of those frameworks around. So the interface is very basic. Yeah, incredibly basic, yes.
I mean, do any of these frameworks support our use case directly, where you're just creating a frame buffer and then spewing out updates over an SPI link?
Yeah, some of the frameworks, I've not looked at the API of everyone, but in a couple, I've seen in the configuration of the library, you can select whether it's a display with, I think, with the embedded memory, or you have to enable the auto refresh in the LCD controller of the SoC.
What should we do exactly?
I mean, I know the question has come up about whether Zephyr supports a graphics library, and the comment is, we're happy to take one, we don't have one today. I don't know whether or not it makes sense to engage with these commercial entities and having them look at having Zephyr support is the way to go forward versus, you know, and I think that's part of the conversation here, just how much demand really is there in this space?
Or very small by the sound.
Not enough for us to give you an engineer.
Yeah.
Right, so
That's a very good answer.
right, and that kind of says how much cost it is to you guys,
Yes.
right, from what your customers are demanding of you, that it's not such a burden that you're like, hey, you know, from an engineering perspective, this would make sense to try to collaborate on to reduce our cost. It doesn't sound like that from anybody. It sounds like, you know, you guys invested whatever was invested a while ago, and now it's really maintenance on top of that.
Yeah, if the future that changed and we were having to do a new investment, maybe it would make sense to do that investment collectively, right? But we haven't seen it.
Yeah, after maybe another way to look at it is the way shown by R, that if some GPU vendor see an interest to propose something that could fit in this area, we can think that they will also propose some software pass for it.
In one sense, you guys are customers of whatever the GPU guys do, acceleration guys.
Oh, by the way, do you see some GPU vendor looking at it or approaching the
I haven't seen any GPU vendors. I think we've seen more system companies, you know, people trying to build something on top, potentially looking for, probably needing some simple graphics display support, and just that, there's not a use case or an example of that today with Zephyr. So I think it's just a matter of, as Zephyr progresses and so forth, I think whether it's, again, an integration with one of these, whether it's maybe we do, you know, something's done with eGUI, you know, as being an open source, you know, integration, just to demonstrate a capability more than anything else at this point.
So the action that we could take off today is to keep these on the agenda, monitor the evolution, and keep synchronization with James.
I think
And-
we've had
and plan
useful
for-
things out.
Yes.
We can talk.
Okay.
There is a suggestion that if you create this, the market will follow. There are
Yeah, but that's the idea behind it. An awful lot of software.
that's the problem. It's hard to get the investment. And obviously, if you were doing something in Zephyr, we would be happy for our scientists to work on it.
Yeah, okay.
So
I think the short answer is go see Professor Zuko's talk on Friday.
okay.
Is he here? Yeah, he is. I saw him earlier. Okay, is he here? I know. Okay.
Okay, so we will keep this for further updates in the future light steering committees.
Yeah, but it's useful input. Thanks for the input.
Thank you.
All right, cheers.
Thanks everybody.